Next up, we have Justin Ryburn from Kentik, who is going to be talking about BGP Flowspec. It doesn't suck, we're just using it wrong. So hopefully that will be useful and good information, and we'll learn how to use it correctly. So I'm going to let Justin take it away. Please welcome Justin up on stage.
All right, thank you, John. As we get started, I'll just do a quick introduction of myself and why I chose this topic. So currently the field CTO at Kentik, as John said, but early in my career, I was an operator and had the pleasure of getting those 2 o'clock in the morning phone calls for an escalation to track down a DDoS attack against our network. Worked with probably a lot of you in this room to try and track those back to the source using very crude tools like SNMP metrics on an interface, creating a firewall filter on the interface, and doing accept any and trying to figure out what the source of those packets were and track DOS attacks back to their root. So that brings me to the next topic, which is this really still a problem? We're now, almost 25 years later from when I started having to do this early on in my career. And yet it's still a problem we deal with as an industry. All of the articles that you see here on the slide may be a little hard to read, but the point is it's still a problem. There's still articles almost every day about attacks against internet infrastructure, DDoS attacks against the network. So this is actually still a very real problem that I'm assuming I'm probably preaching the choir up here. A lot of you are dealing with on a daily basis. We're still trying to figure out a good solution to this. One of the interesting things I see when I talk to our customers about DDoS detection, DDoS mitigation, kind of the state of the art, the state of the union, if you will, on these types of things, is that they really want to do this in the cloud now. There's a migration or a trend, if you will, away from on-prem scrubbing appliances, running the attack traffic through a scrubbing appliance to clean that traffic, the attack traffic out, deliver the clean traffic back into the network. That approach seems to be going a little bit of the way of the past, and really doing cloud scrubbing and consuming it as a service. Or if you're a large operator and have the resources to do it, building your own scrubbing center where you redirect that traffic into a particular part of your network that scrubs that traffic and reintroduces it. That seems to be the trend that I'm seeing when I'm talking to customers, especially the enterprise customers, but as well as some of the service provider carrier customers as well. This is just an example. One of the things that we're able to see is the routing tables and visualize those routing tables, which allows us to be able to see when a company is triggering a cloud scrubbing mitigation. So in this case, this is a company called Intrado Life and Safety, ASN 36329. They normally use AT&T, AS7018, as you can see, for their transit provider. That's who they get their internet connectivity through. That's who their traffic is delivered into their network from. But presumably they were under attack, because we can see for a period of time there, they actually stopped advertising their routes upstream to AT&T and started advertising them to Newstar, which is AS19905. This is just an example. They're then presumably having Newstar's cloud scrubbing service scrub that traffic and inject it clean back into their network. So before I dive specifically into BGP Flowspec, I don't want to make this sound like there aren't other options. There are other options potentially that exist, that if you're trying to find a solution for DDoS detection, you should definitely consider. Like anything else in engineering, there are trade-offs, there are pros and cons. So I'll walk through a little bit of each of those as we go through them. This was the way that I was kind of describing early in my career. We wound up having to do it because we didn't have a lot of options back in those days. And what it really came down to is you see this traffic coming in on the left side of this slide from the little red hacker guys across the internet, all the way over to the victim here on the right side of the screen, right? The only option back in these days that the victim had was to call up their friendly service provider, call up the network operations center, the security operations center at their friendly service provider and say, you got to help me, I'm under attack, trace this back, block it, And the state of the art, like I said earlier, was looking through S&P interface stats to figure out where that big spike in traffic was coming in to the network on, try and figure out what the source of that was, work with the community to try and track that back to the source and block it as close to the source as possible. You know, it has some pros and cons. It is, I mean, reliable. You can get very granular when you create that firewall filter or that access list on that interface. You can block it based on, you know, a 5-tuple of source and destination port and protocol. You know, it is pretty robust in that way that you can get very granular in what you're blocking. If you need that applied on all your routers, that can be very time consuming, especially if you're running a large distributed edge network with lots of routers. Logging into the CLI on every one of them is, you know, probably a non-starter. That can be automated. We did that in the network that I worked at back in those days. We would automate pushing out edge ACL filters. I will say I have bumps and bruises from pushing out a script and blocking the wrong thing. Turns out, and I'm not picking on Cisco, but in Cisco's iOS, if you remove the ACL but don't de-apply it from interface, it just denies everything. And that's a really bad thing to do on a peering interface, it turns out, especially when you do it in a script and push it out to all your peering routers. So, you know, there are definitely some pros and cons to that approach. As an industry, kind of the evolution then was this remote trigger black hole, right? The concept of being able to use BGP to advertise a route that allowed us to block that traffic. And what my network did, what I think most networks did, was we have this community that's a special community on the BGP routes that we reserve, we maintain specifically for this purpose. So any route that's advertised that has that community, rewrite that next hop, as you see here on the slide, to a discard, right, or to a black hole, and discard that traffic. Definitely allows you to do more of a dynamic, automated way to block that traffic at the edge of the network without having to log in manually, without having to be concerned about scripts going wrong and you know, causing an outage in the network. You know, the downside being you pretty much are doing what we call completing the attack, right? That poor victim that's under attack, when you do this, that IP address is now no longer reachable on your network, so they're completely offline, right? If you're able to protect collateral damage, maybe you have a victim that's sitting next, or non-victims that are sitting next to that, hanging off the same backbone links. If that protects the rest of your traffic, they wind up having to be collateral damage. I mean, you know, you got to do what you got to do with the tools you have available. Again, pros and cons here. You know, it is an RFC. I mean, it is something that a lot of people are using. It's well known in the industry. So, I mean, it is something that can be done. I still do actually see quite a few customers using this, like I said, especially if they're having collateral damage. It's not just the victim that is being impacted by the attack. The remote trigger black hole can definitely help with that. Kind of a newer thing, gRIBI is another way we can potentially deal with these type of attacks. gRIBI basically acts as sort of an injection into the routing table. So it's almost like its own routing protocol in that way. It has a administrative distance or a protocol weight just like BGP or OSPF or any other routing table or any other routing protocol. So you can inject a route directly into your network to block these type of attacks. So, you know, that's another thing. If you haven't taken a look at that, haven't played with that, you might take a look at gRIBI. That might be something that can really help you. Like I said, it can be used to send routes directly to the RIB. So it's not it's not sending it directly into the FIB. It is sending it into the RIB and then allowing the device to then process that route and push that down to the forwarding table. So it does have, you know, some safety mechanisms around it. It can be used to redirect traffic to the scrubbing center like I was talking about earlier. So that's one of the benefits of gRIBI is you can change the next hop and point it to a scrubbing service so that you can redirect that traffic into a scrubbing center and block the traffic that way. You know, the one downside that I see with it is, as far as I can tell from reading the specs and so forth, there's not a way to do that granular matching of traffic like I was talking about earlier with the firewall filter or the ACL, where you can really get down to like the 5 tuple of source and destination port and protocols and IP addresses. So it's not quite as granular as what you can do with an ACL, but might actually be better than the remote trigger blackhole. Definitely can be used to redirect to a scrubbing center. So again, pros and cons, something worth considering there. All right, so now I'll transition to talking about Flowspec, start with an overview for those who are not familiar with Flowspec or haven't taken a look at it in a while and how it actually works. So what it does is we're actually adding a new AFI and SAFI to the BGP capabilities that the two devices are transmitting to each other or exchanging with each other. Because of that, just pro tip here, most routers, if you're adding a new capability, a new AFI and SAFI, they do have to reset that BGP session to negotiate that capability between the two of them so that they can exchange those type of routes. So that's something you're going to want to do in a maintenance window because your sessions are going to bounce. So just, you know, something you want to either test in the lab, definitely deploy during a maintenance window because that will potentially have impact on your traffic. So, you know, obviously be careful of that. You know, another thing that I see a lot of companies doing is actually configuring a separate session just for that capability. So instead of adding it on to an existing session they may already have between their devices, creating a second session specifically for turning on Flowspec. So that's another way you could potentially address that limitation of the session rebooting, is just have a completely session for doing the Flowspec signaling. So another idea there. But either way, you're going to have to turn on this capability so that the devices can advertise Flowspec type routes. So in order to do matching, to figure out what traffic we want to match against to block this attack traffic, it creates a Flowspec, as the name implies, in an NLRI. So that AFI and SAFI advertises a new NLRI. The NLRI tells the device that's receiving that what are the matching criteria that I want to match on. And you can see the full list here on the slide. I won't go through all of them, but what you can see is that it can get very granular, right? It gives you that level of granularity that you have with a manual access list or manual firewall filter on the device without having to go in and manually configure those, right? So that's the advantage that we're really after, at least in my mind, is the advantage that we're really after with BGP Flowspec, is that level of granularity. The one thing I have noticed a couple customers get confused on is type number 4, right? So type number 4, you'll notice, is source or destination port. That will be interpreted by the router as either one of those. So like, for example, if I give it type 4 and the number that I give it is 53, it's going to match on any packet that has a source port 53 or a destination port 53. And I think most operators probably really want either type 5 or type 6 so that you can tell it, do I actually mean source or do I actually mean destination? So just, you know, make sure that's actually what you want if that's the type you're going to use there. All right, so once you've done a matching, the next thing you obviously want to do is take an action, right? I think blocking is probably the most obvious action that you can take on this traffic, but there are other types of things that you can do. You can do redirection to a VRF. So again, if you're going to redirect to a scrubbing service, you can redirect it into a VRF. By the way, the reason you would do that is if you don't put your clean and your dirty traffic in two different routing tables, put one or the other of them into a VRF, you're going to create a routing loop in your network. So what's going to happen? You're going to have attack traffic come into your network. It's going to hit the Flowspec rule, which is going to tell it to redirect to my scrubbing center. Then it's going to come back into the network, hit the Flowspec, say redirect into my scrubbing center, right? So you got to separate the two. So you got to have either your dirty traffic in a VRF or your clean traffic in a VRF, one or the other. Clean traffic VRF is what I see most commonly in practice. So that's an action you can do. Interestingly, you can actually rate limit it. And in order to block, you actually do a rate limit of 0. That's what that first action is talking about. So you could rate limit it not to 0 if you wanted. If you just want to squash that traffic and bring it down to a rate that it's no longer causing collateral damage on the rest of the network. That is a possibility that you could do. I've not ever seen anybody really doing that in practice, but it is a possibility. More commonly, people just set the rate to 0 and drop the traffic. So what makes BGP Flowspec better? Why do I feel like this is a better approach than some of the other approaches that we talked about earlier? Again, the first one that I've been alluding to is it gives you that same level of granularity that your access list or your firewall filters give you, right? We have all those rich matching criteria. We can get more granular in what it is that we're matching on, what it is that we're going to drop. You also get the similar automation that you get with remote trigger blackhole. Not automation in that there's code running to do it, but automation in that it's dynamically advertised across your network. So it makes it much easier to propagate that filter that you're wanting to create out to all of your edge networks without having to log in, without having to write the code to manually log in and do those network firewall changes. A lot of people would say, well, this is kind of overloading BGP. Like, that's not what it's really designed for. It's not designed to exchange information about firewall filters. It's designed to advertise routes. I respect that opinion, but the thing that BGP does bring to the table is we've been using it for a long time. The internet is built on it. We all know how to use it. It has policies. It has controls in place. And so putting this on top of BGP allows us to leverage that existing infrastructure that's already out there for policies, for filtering, and it's a protocol we already have running in our networks anyway. So it's not requiring us to roll out a whole new protocol for that. Some of the drawbacks that Flowspec has, it's not without its problems, right? Otherwise I wouldn't need to stand up here and talk to you about it. Everybody would just go do it, right? So there are some drawbacks to it. A few things that I have seen customers stumble on is the transmit-only nature to the forwarding plane. So if you advertise a Flowspec to a device, the device then processes that, converts that into essentially a firewall filter, pushes that down to your forwarding plane, right? There's no ACK mechanism back from the forwarding plane to the control plane saying, yep, I got that, it's being implemented, right? You have to go in and figure out through show commands or collecting stats to see whether that was actually implemented, whether that actually took effect, right? So it's one of the advantages that gRIBI does bring to the table. There's an ACK mechanism for everything that gRIBI is pushing out to the device. It's getting an acknowledgement back so that kind of bi-directional feedback loop that what you intended to do actually was done. It is missing there with BGP Flowspec. The other thing to keep in mind is there is this concept of rule ordering. For those of you who have ever built firewall policies, you know that rule ordering is very important, right? It's going to go down through the list of the rules, and it's going to hit the first one that it matches, right? That's going to be a problem if you scale out Flowspec and you have overlapping prefixes that you're matching against and you're blocking. Your rule ordering becomes very important, and that's something that at least in the original RFC, Flowspec doesn't really address is how do we figure out how to add, like, I want this rule to be number 1 and this one to be number 2. How do I do that ordering? There's not really a good system for that in BGP Flowspec. Adoption rate. So this is an interesting one, like where are we at? I mean, Flowspec has been around now for a number of years. I actually did a talk about 10 years ago at NANOG about Flowspec, so this isn't something new. It's been around for a while. Where are we at? So I went over to ChatGPT and I said, hey, where are we at on DDoS attacks? And, as you might expect from AI, it gave me a real high level answer that didn't really answer my question, but, it's interesting nonetheless. But in all seriousness, it's actually hard to get a handle on. I have not seen a lot of great research in this. I haven't seen a lot of data points or news articles on who is running this. But if somebody knows something, there's some research that has been done, I would love to have that brought to my attention. Send me an email or let me know. I'd love to know about it because I think this is an area that could use some research for sure. Just anecdotally, I will say I talk to a lot of customers. My job sends me all over the place talking to a lot of not only our customers, but other people at conferences and in the hallway tracks here at NANOG and so forth. It's definitely a frequent discussion. There are a lot of people who are labbing it up. There are a lot of people who have it deployed in production. There are people who are iterating, trying to make it work for their networks, finding the scaling limitations and so forth. So it is definitely something that people are doing. It's not just academic. There is actually production deployments of BGP Flowspec. What are the numbers? I don't know. I don't have great numbers. I'd love to see those, but I just unfortunately don't have them. I alluded to a few best practices we went along, but I wanted to cover a few more here in this next section. I think this is actually an area where people have come to the conclusion that I alluded to in my title, which is that BGP Flowspec sucks, right? That it's bad, that the technology is not helping us. Part of that is because it is a big hammer, and when it goes wrong, it goes really wrong. And there's been a number of very public and very prolific outages that have taken place. I think the original and maybe most well-known was the second one here on the slide in 2013, the outage that Cloudflare had in their network. Both of these companies were pretty transparent in explaining what went wrong. So if you want to read a little bit more about those outages, you can download these slides, click on that link. And I'll talk a little bit about the Cloudflare one here and what I take away from that, what we can learn from that as an industry, some of the best practices that we take away from this. But CenturyLink also had one in 2020 during the pandemic. Well, if I remember correctly, it was right before the pandemic really took place. But in 2020, CenturyLink had a very very big outage that I think most people are probably familiar with. So we have had as an industry some very big outages because of BGP Flowspec being deployed wrong or in ways that were unintended, I guess I will say. So what can we learn from that? That's really the point. It's not to pick on these two organizations. It is what it is. We'll all make mistakes, but what can we learn from that, right? The number one thing is, of course, test, and test again, right? As we as an industry know this, before you put something in your production network, you need to make sure that you're deploying it in the right way. You need to test it in the way that works for your network, for your environment. Like I said with the Cloudflare outage, there are a few things that I took away from that I think we could learn as an industry. The first one was, let me back up. What actually happened with the Cloudflare outage is they announced a BGP Flowspec route to the routers on their network, the edge routers on their network, that happened to have a byte length of 99,971 to 99,985. Now, you're probably all sitting there going, that doesn't make any sense, Justin. You can't have a packet that big on any network I've ever heard of. Even a jumbo frame doesn't go that big. And that's actually the point. What happened was the vendor's router that received this, saw that, didn't know what to do with it, and had a kernel panic, and so the forwarding plane crashed, right? Now, I would argue that the vendor's router shouldn't have had that panic, shouldn't have crashed, but also, this is something that now that we know about it, you could do a check for in your automation code that's creating these flow specs, sending these flow specs out, is to make sure you don't cross a boundary of what the MTU is on your particular network, right? So this is something that we could check for, right? Again, testing at scale. A lot of customers I talk to, they're like, hey, what should I be testing for? Like, what are the common challenges that you see in a deployment? I think one of them is what happens at scale, right? It's great if I'm only blocking one attack, and if you're fortunate enough to only have a small network that only has one attack at any given time, congratulations. But I think most networks are dealing with more than one attack that they're trying to block at any one time. So how do we scale this out in our network? That's something that needs to be tested in the lab, and a couple of reasons for that I see. One is forwarding plane resource exhaustion, right? In your forwarding plane on any modern router, there's not an unlimited amount of resources for packet filtering, right? So the question is, at what point do I run out of resources? It's going to vary from chip to chip, so there's not one good answer that I can stand up here and give you. You can ask your vendor if they have stats on that, but the best way to figure it out is to do lab testing of it, right? Because it's also not a binary thing. Like, let's just say the number's 10,000. It's not quite that simple. What you will actually see if you do the testing is, as you scale up the prefixes that are in your network, as you get closer to resource exhaustion, you'll start seeing forwarding plane performance drop off. So you can no longer forward at line rate because you're reaching resource exhaustion. So it's not like it's just a number that you hit and you just go to zero. It's a slow decline. So you want You want to test that at scale, at the scale you think you'll need as far as how many Flowspec routes you'll be injecting at any one time. And they're not all created equally as well. So the resulting firewall filter that's created in the forwarding plane from a very simple just destination IP address match is much easier for a router to implement, and it uses a lot less resources than a more complex one that's doing a whole 5-tuple match and matching on QoS markings or something like that, right? So the more complex you make the flow specs, the more resources it's going to use in your forwarding plane. Kind of alluded to this earlier, but each chipset, each line card version may have different resource limits. So if you've got multiple versions, multiple generations of line cards in your network, you want to make sure you're testing it on each one. Don't just grab the latest and greatest and assume that all the older ones are going to have the same forwarding performance at the same level of flow specs. You're probably going to be sadly disappointed that that's not the case. I already talked about the flow spec rules not being created equally. I think the last thing is just roll it out slowly, right? Like anything else that we do in network operations, you want to test it quickly. You want to test it slowly. You want to roll it out slowly. Test it in maybe one market or one area of your network. Try it at a low scale before you start scaling it up. Get some real world experience for how it works in your network, in your environment, before you go rolling it out everywhere. I alluded to it earlier, but you want to monitor your forwarding plane resources too, right? Might be something you could script through going in and doing some show commands. Each vendor typically has show commands that you can use to see what your resource exhaustion looks like in your forwarding plane. Pull those back into a script, keep an eye on those so that you can see what the impact of your forwarding plane is as you get closer to resource exhaustion. Maybe that's something you can even get SNMP or streaming telemetry data and collect that and keep an eye on it. All right, so next steps. I encourage everybody to stay current on the latest. The IETF is constantly working on the flow spec RFC. There's actually a new one that came out, I think, about 3 years ago that came from operator experience dealing with this in their production network. So getting feedback from operators that are struggling with various aspects of BGP Flowspec helps the IETF ratify new RFCs and make it better for everyone. So check out the work that they're doing, join their mailing alias, give them some feedback if you're testing this and deploying that on what's working and what's not working with you. So as an industry, we can continue to iterate and make things better. This is a great thing to talk about with people here at Nanog in the hallway track, at Beer and Gear, when you're talking to your colleagues. Find out what their experience is. What are they planning on deploying this? How are they handling it? What have they seen in their network? That's honestly where I get the majority of the material that I put in this presentation, is just from conversations I have with people about how it's going and what they're working on. So I encourage you to ask those questions, talk to people while you're here at Nanog or at other conferences. You're always welcome to reach out to me. I'm happy to answer any question that I can. I'm not going to stand up here and say I know everything, but I'm happy to answer any questions that I might be able to. And then I've got a few resources here, some QR codes if you want to scan those, or you can download the slides and click on these links. There's some additional materials here that may help you as you're testing and working on BGP Flowspec. So yeah, in summary, it's still a challenge that a lot of us are dealing with. DDoSs are not going away anytime soon. Mitigation can be difficult, but I believe that BGP Flowspec can help be part of that mitigation, assuming that it's done correctly. It's slow to be adopted, but it is getting there. As long as we test it, roll it out slowly, I think it is a technology that can really help us deal with these DDoS attacks. And again, share your experiences, share what you're learning, share with your colleagues what's working and what's not working. With that, I know we got only about 1 minute left, but I'm happy to take any questions.
So if anybody has any questions, please come up to the mic. Make sure you introduce yourself, name and affiliation, and be brief. Do we have any questions from the remote audience at all? Negative. Okay. Go for it.
Okay. Am I okay to go? Okay. Tony Tauber, Comcast. One good talk, good overview. I think something else that people might want to keep in mind is when they're thinking about troubleshooting any problems that may come up from Flowspec is, A, there may be a different team than the router jocks who are, sending the rules out if they're the DDoS mitigation team, say. Another is that if something goes awry, a reflex might be, oh, let's look at the config, all the config changes that have taken place on routers in the time period that we're interested in. And since the Flowspec stuff is soft state and it's coming from some other automation
It's not in the
system,
config, so
maybe,
it's hard to
and
figure
some
that
other
out.
group, just have in mind or, train your folks to say, oh, it might be that.
Fair point. Thanks, Tony.
Adair Thaxton, Internet 2. Just wanted to point out, as we were testing a new platform a couple of years ago, one of the things that we verified using Flowspec was that you actually can block IP addresses that are integral to routing protocols, like 224.0.0.5. So if you have like some automation or some double checks on your Flowspec rules, definitely put some guardrails in place as best you can.
You mentioned no defined behavior for rule ordering for Flowspec. My assumption would be most specific rules come first, but have you seen any vendors that are specifically weird with their behavior in terms of Flowspec rule ordering?
My experience has been it just goes in order that they were received, not
Okay,
most
so oldest
specific.
route.
So my advice would be kind of to Adair's point, and whatever code is creating the flow specs and putting it out, put those type of checks in place where you can't have overlapping so that you know that you have a deterministic behavior. Otherwise,
Okay.
could fail in very weird ways. And kind of to Tony's point a minute ago, like your operations team is going to really struggle to figure out how to get to root cause on that.
Understood. Thank you.
Last question, real quick.
Maria, developer of BERT. I'd like to point out that if I remember correctly, having two different sessions for BGP, one for Flowspec and another for the regular routes, should result in invalid Flowspecs. If I remember correctly, the RFC. The other thing, I don't know whether there is a preference or an ordering inside the RFC, but if there isn't, there is a reason. Then this is a reason to edit. So if there is, I don't remember whether it's there or not, but if it's not there, I am taking this as a note and I will try to push it into the IDR if somebody didn't do it before.
Sounds good. Thank you.
Great. Thank you very much.
Yep. Happy to do it. Thank you.